So your central angle has a vertex at the center of a circle. And its two sides are, okay, I don't really know how to spell this. Radii? It feels wrong. I don't know. Radiuses, that's for sure not right. Multiple radiuses, okay? So what you see here at, for example, it says, for example, angle ABC is a central angle. So I will highlight it. We're talking about this guy. Oh, look at him. Okay. You just told me, and is a central angle in circle B to the left. The sum of all central angles in a circle is how many degrees? 360. If you add up all the central angles, it should add up to 360 because that's how circles work. Okay. Go all the way around. To measure the arc formed by the endpoints of a central angle, it is equal to the degree of the central angle. So angle measure, obviously, you guys are familiar with. What's a little bit unfamiliar to do is probably what you see here, where it's got like that arc symbol over it instead of angles. And so it's saying measure of arc AC. We measure arcs and angles exactly the same way. And so what you see here, if the central angle is 84 degrees, the arc measure is also 84 degrees. So measure of arc AC is also 84. Can you subtract from 360 real quick? What would be the measure of ADC? That's the major arc that goes the rest of the way around the circle. Okay, so ADC goes the rest of the way around. And it's how many degrees? 276. That's all you gotta do. Okay? So again, I'll highlight which one we're talking about here. Talk about ADC. This is a major arc. Why? How do we know this? It's got 3 letters. So it has to go through all 3 of those letters. This guy here is the minor arc. It only has 2. Okay? But notice that they are measured just according to the angle measure, so it's super easy. We're not going to do all these examples because that would take forever. But if you could look at example 4. Okay, obviously you know that the central angle there is 22 degrees. So that means that your arc measure is also 22 degrees. So please watch and look and cease your side conversations. So if this is my central angle, SQT, the arc that it's connected to right there is also 122, okay? But ST, you got to follow the letters, and obviously for arcs, we're only going to use 2 if it's a minor arc. The only time you use 3 is if it's a major arc. So then we're talking about like pieces of a pie, okay? RT would be a diameter, so you need to subtract probably from 180, right, to get SR. If I subtract, then 180 minus 122, do you have? 58, yes. Okay, SRT, please watch and learn. You need to follow the letters all the way around. That's a major arc. It tells you it's going to be more than half. So SRT is all, I'm going to use a highlighter, sorry. Take 2. SRT goes all the way around. So you can basically ignore the 58, right? Because what you can see is that, well, it's everything except for the 122. So you could do 360 minus 122. You're just, or you can add up pieces. You could do 180 plus 58. It doesn't matter. It should be. If you subtract, so I did, I think, 360 minus 122, but it doesn't actually matter how you do it. It is 238 degrees. So major arcs will always be greater than 180 degrees, because it's going to be more than half a circle. What you need to watch out for is when do you have diameters? Only when you have diameters intersecting do you have, I guess, what you could think of as vertical angles, right? And so if you look in the problem 5, you've got 21 degrees. So the one across from it is also 21 degrees, right? Because we know that vertical angles are congruent. And so yes, you could label this guy 21 degrees as well, which tells you that the arc measures are also 21 degrees that they're connected to. We'll fill in the blanks in a second, but what would this arc be? Maybe I should say this central angle. What is that central angle? JNM. You can clearly see MK and LM or LJ are diameters, so subtract from what? Half the circle will be 180, so you're going to subtract from 180, and you show that missing piece. What is it? 159. And then we should probably be able to answer everything. These are also vertical angles. So JK is talking about, I'll just mark them as I go, I guess. JK is talking about this arc right here. So that's the same measure as the angle that it's connected to, 21 degrees. JNM is the central angle that we already highlighted. That's 159. It says measure of arc KL, but not that that really matters, because if you know the central angle, you know the arc measure. So KL, what is it? 159. JKM is talking about a major arc. I know that because it has 3 letters. So J, K, M, all the way around. Add them up, or you could do 360 minus 159. Figure that out real quick. What's really helpful, obviously, in these problems is to mark up your picture with everything that you can figure out, because then when you're finding the pieces you have to add up and stuff, it's just easier. What do you have? Is not 180 because you're going all the way from J to K to M. So you're going to add up another 21 degrees. So it'll be 201. Because you're doing that 180 plus an extra 21. Okay? JKM, did I do that right? Yeah. Has to connect all those 3 points. And then MKL, again, follow the path that it creates. I'll do this in blue. MKL. You have to follow the direction it tells you. Okay? So it's everything except for ML, right? So everything except for 21 degrees. So what would that one be? You can do 360 minus 21, so it's going to be 339. Okay? I'm hoping this is pretty straightforward. All right. What do you notice about RT? What is RT? It's a diameter. Yep, it goes all the way across. And diameters cut circles in half, creating semicircles. That's what's called a half a circle. So since this guy here is a diameter, that chord, then you know that those two add up to how many degrees? 180. You could also use vertical angles, I guess, to put 26 and 15x minus 26 on the other side as well, and then add to 360. It doesn't actually matter. But I'm going to do, 15x minus 26 plus 26 equals 180 because that's a diameter. Looks like you've got some like terms that actually just cancel out. So, or add to 0 rather. 15x equals 180. You can divide by 15 and you get 12, I think. Okay. So it's really just a puzzle. Like, find your missing pieces. Figure out what they add up to. We're not doing the next one because I trust that you could figure it out. When in doubt, try and solve for something that's missing, especially if you have a diameter, you know, like, oh shoot, this half the circle is 180, so then I could subtract from there. Okay, we're going to do number 10, and that'll be the last one we do. You've got everything labeled except for VZY. Let's not be confused about that. What is that one? It's a right angle, so that tells you that this arc measure is 90 degrees. Okay. So you have all the way around the circle. Lovely. How many degrees is it all the way around the circle? 360. Okay, so combine like terms, folks. And make sure it's equal to 360. Can you please try that with people at your table and see if you can, when you're done, you're going to plug back in, I guess, for x, right? Which we've done in geometry all year long. And then you should know all the arc measures. Okay, ready to go. Okay, if you know that x is 7, then you can then plug into your other stuff. I usually plug it in the picture, and then I go back and fill in the blanks later, because it's less confusing that way. Okay, check what you have, please.